quite get through it on Monday. This section actually doesn't have a lot of new information. It's just putting together some properties that we've learned in Algebra 1, and we also went over in Chapter 5, Section 1 of Algebra 2. And then using those properties with fractions. Fraction exponents. Yay, right? So on Monday, if you didn't get a chance to watch it, we talked about what a fraction means when you have that as an exponent. And that's another way to write the root of a number. So for example, just to give you a quick review, if you have 6 to the, sorry here, having a little technical difficulties. If you have 6 to the 1/4 power, that would be the same as writing the 4th root of 6. So those are two equivalent expressions. So that was in section 6.1. So the properties that I wanted to review with you guys really quickly. Again, we did all these same properties. In fact, I think I even used the same chart in your notes back in 5.1, so none of these are new. Like I said, we're just going to apply those to fractions, so we'll go over them kind of quickly. So the first is the product of powers. So if you have a to the m times a to the n, you add the exponents together. Okay, so in this particular case, we're talking about fractions. It has to have the same base. If we have 3 to the 1/3 power times 3 to the 2/3 power, they have the same base. They're both the base of 3. We're going to add the two exponents together. So it's going to be 3 to the 1/3 plus 2/3, and I'm going to be lazy about it and write it like this so you don't have to wait. So 1/3 plus 2/3, and we're going to get 3 to the 3/3 power, which is just, of course, 3 to the 1st power, or 3. Okay. We also have the product of a power of a power, excuse me, which is when we have an exponent, a to the m, that's raised to another exponent. Okay. So when you're multiplying, you're going to add the exponents. When you have a power that's raised to another power, then you actually multiply these two together. Okay. So again, if we have 2 to the 1/3 power that is squared, we're going to actually multiply these two exponents together, and you're going to get 2 to the 2/3 power. So same rules that you've done before, just using fractions instead of whole numbers. Power of a product, which means that if you have a and b raised to the m power, then we can basically, it's kind of like the distributive property, right? We can distribute the exponent to each of the terms inside of the parentheses. Negative exponents, this one's going to be important. So if you have a number with a negative exponent, that means that we can also write it as the reciprocal, so 1 over that number to the exponent. This actually comes in handy a lot when you end up with a negative exponent in the denominator. So kind of a reverse of this is that if, for example, you would have 1 over, and let's take a simple case, 2 to the -3rd power, then that's the same as 2 to the +3rd power. Okay. Or if we had 1 over 2 to the -3/4 power, then that would be the same as 2 to the 3/4 power. We have the quotient of powers, which is a to the m divided by a to the n. So this is kind of the opposite of the product. These two are related to each other. If you're doing multiplication, you add the exponents. If you're dividing, then we subtract the exponents. Okay, and then the power of a quotient, again, similar to power of the product. This is kind of the idea of distributing. If you have a divided by b all to the m power, we can rewrite that as a to the m over b to the m power. So I think those should all be things that you've seen before, but just kind of wanted to review through those quickly. So 6.2 is basically we're going to use the same properties that we've been using throughout algebra, but we're going to apply it to non-whole number exponents. So we're going to use that for fraction exponents. So let me clean this up a little bit. Go back here. Okay, so we have a couple examples on the bottom. The first one is we have 6 to the 2/3 power raised to the 1/2 power. So the idea is to simplify all of these terms. So this particular one is the power of a power, right? We have an exponent raised to an exponent. So what we do in that case, when we have an exponent raised to another exponent, we multiply the exponents together. So for this particular number 1, what we're going to want to do is 6 is our base. That stays the same. And we are going to have 2/3 times 1/2. Okay. And we need to multiply those together. It's a multiplication there. So 2/3 times 1/2. Remember all your fraction rules, right? So we could rewrite this as 6 to the 1/3 power. That would be one way to write it, right? Or we could write it as the cubed root of 6. Both of these would be valid ways to write the same expression. Okay, so that's the first one. And number 2, we have 9 divided by 9 to the negative 4/5 power. So I have a fraction bar, so I know I'm going to use something with quotient, right? I have the same base. They're both a base of 9. And anything that doesn't have an exponent, so this 9 doesn't have an exponent, we can assume that it has an exponent of 1, right? Because that just 9 to the first power is 1. So what we see here is when we have same base, our base A is 9, we can actually subtract the exponents in order to simplify. So what that means is we have 9, that's like our A, right? 9, and then our M in this case is 1, 9 to the 1 minus, and then in the denominator, the N is negative 4/5. So the exponent in the denominator is negative 4/5. So 1 minus negative 4/5. Okay. So then when you are subtracting a negative, that's like adding a positive, right? So we're subtracting a negative number, that's like adding a positive. So basically we have 1 plus 4/5. So we could say that this is 9 to the 9/5 power. That's crazy writing there, but I think you guys get the picture. Okay, example number 3. So one thing to note about example number 3 is that we have 120, and 120 is the base, and then we have 7 as the base. So in order to incorporate our rules, we could not, for example, use the quotient of power rules on this fraction as it's written because they have a different base. This has the numerator has a base of 120 and the denominator has a base of 7. So what we should probably do is deal with these two items that have 120 as the base, because we can do that and then figure out what to do from there. So we have 120 to the negative 2/5 power times 120 to the positive 2/5 power. This is my product of powers, right? I have the same base, 120, and 2 fractions, so I'm going to add those 2 fractions together. So I have 120. I'm multiplying across the numerator, so assume this has a 1 at the bottom, right? I have 120 to the negative 2/5 power plus positive 2/5 over, Sorry for the crazy writing. 7 to the negative 3/4 power. Okay. Well, this works out nicely because my exponents cancel each other out. So I end up with negative 2/5 plus positive 2/5 is just 0, right? So 120 to the 0 power. And anything with a 0 power is 1. So now I'm just down to 7 to the negative 3/4 power in the denominator. So I could leave it as 1 over 7 to the negative 3/4 power. However, there's one more rule, the negative exponent rule, which allows me to flip from the numerator to the denominator or the denominator to the numerator if I have a negative exponent. So it would be nice not to have this negative exponent. And I can fix that by flipping the 7 to the negative 3/4 in the denominator to positive 7 to the 3/4 power in the numerator. So that's how we would solve that. If I could write that right, let's undo that. Okay, so there's a few more examples on there, but I actually think I am going to do a few from your book because I like them better than what I have listed there. So let me clear off my screen here. I am going to do number 35 first. So this one's from your book. So I have some more examples, but I think these will be more helpful to what we were doing. Okay. So number 35 is not a specific power that we talked about, but hopefully you'll recognize the pattern based off of other things we've done. So 35 in your book is 1/8 times the 4th root of 7 plus 3/8 times the 4th root of 7. So the idea is to simplify this. So what you'll notice is, thankfully, both terms share 4 to the 4th root of 7. They both have that in common, right? And for those of you that know me, my favorite property is the distributive properties, but we can also undistribute these. We can pull these out of each term, right? And we would end up with 4 4th root of 7 times 1/8 plus 3/8. Okay. And we can simplify this, right? 1/8 plus 3/8, that's easy. It's 4/8 or 1/2. So 35 we would write as 1/2 4th root of 7. Okay, so if you see an addition or subtraction problem in there, you can kind of treat these as kind of like a variable that you can pull out of the equation, and that's still a valid way of solving those equations. Okay. The next one I want to do from your book, kind of to give you a different example, let's pick lavender, purple marker, right, is 47. Actually, I'm going to start over now. Let's see. Keep it nice and clean. 47. So 47 is x to the 2/5 power times y divided by x times y to the negative 1/3 power. So just because we have a fraction in our exponents does not mean that we can just, it doesn't mean that all the rules don't apply. So we can still kind of group this problem into two sections. So we can say one is that we're going to simplify the x's because those are our like terms. And the other is that we're going to simplify the y's. Okay, so we have x to the 2/5 divided by x. So we're going to use our quotient powers to be able to solve this, right? So we can subtract 2/5, and since we don't have an exponent here, we can assume it's 1. So we can rewrite x as x to the 2/5 power minus 1. Okay, this is all up in the exponent. And then we have y. So y has that, again, that assumed 1. Y to the first power minus a negative 1/3. So now we need to do some fraction simplifying, right? X to the 2/5 minus 1. So 2/5 minus 1 is going to give us negative 3/5. And y to the 1 minus 1/3. So 1 minus 1/3 is like adding 1/3, right? So it's going to be y to the 4/3 power. So we're getting there. So again, when we simplify these, mathematicians don't like to have this negative exponent. They want us to go ahead and use our powers to move exponents. And we can move negative exponents if they're in the numerator to the denominator. So we're going to have y to the 4/3 power divided by x to the 3/5 power. And we did that because it was x to the negative 3/5 power. And by our properties, we're allowed to move a negative exponent from the numerator to the denominator. Right, and one last one I wanted to do from your homework, just to give you one other example, is number 57. Okay, number 57. We have the cubed root of x cubed divided by x to the 4th. Okay. All right, so what we want to do is, we know that another way to write the cubed root is to write it to the 1/3 power. So we can rewrite this as x to the 3rd power over y to the 4th power, all raised to the power of 1/3. And that's from section 6.1, where we learned that cubed roots are the same. We can write them as fractional form. Now we want to use that property. It's not called the distributive property, but the one where you can parse out your exponents to each component. So we're going to have x to the 3rd power times 1/3. Well, that's an easy one, right? And we have y to the 4th power times 1/3. And when we simplify that, we get x. 3 times 1/3 is just 1, so it's just x to the 1st power, or just x. And our y is to the 4 times 1/3 power, so it's y to the 4/3 power. Okay, so this is what I came up with when I went to check my work.